Hello everyone, this is HARRI SASTHAA final year BE CSE and the presentation is for the RECode competition by Coding Club. So let's move out to my problem statement. The problem statement that was given to me, given an integer n, create an array of size 2n that contains exactly 2 instances of every number from 1 to n. So any number will be given which can range can be in any integer, and what we need to do is basically create exactly 2 instances of every number from 1 to n. So if for example if n is 2, so we have two numbers from 1 and 2, so we need to create 2 instances of both the numbers, and the number of elements between each 2 instances of a number I must be equal to I. So if we see, we need to fill it up in an array which will basically be the size of 2n. So if the numbers are 2, the array size will be 1, 2, 3, 4. And while filling, we should make sure that the number of elements between the 2 instances of any number should be equal to the number itself. So we should be keeping 2 and 2 at those places when there will be at least 2 elements between them. So this is what the problem statement is saying. And when if no such arrangement is possible, output not possible. So we should make sure, for example in this case only, if input is 2, so 2 we have kept in 2 places. If we try to keep 1, but I will not be able to put any element in between the 2 instances of the 1. So in these type of cases, we should be giving not possible as the output. So this is what the problem states, and we are being giving 2 input examples for understanding the question. When we are putting 3 as the input, so we are giving the output as 3, 1, 2, 1, 3, 2. So with this example, we can understand very nicely that since if we see the 2 instances of 3, there are 3 elements in between them, 1, 2, 1. In the similar manner, when we see the 2 instances of 2, we can see 2 elements 1 and 3 in between, and at last when we see the 2 instances of 1, there are exactly 1 element in between. So it satisfies all the property that is being put up by the question. So now we'll move up to the algorithm for the question that I brought up. So the algorithm for the question, basically first we'll be starting up with an array creation, and the size of that array creation will be basically 2n, where n is the input of the element that will be coming to us through the console. And then we'll be putting a recursive placement where we'll try to keep the largest number. Basically we'll be trying to keep place from n to 1. For example, if we are being given n equal to 5, so how we will go is basically we'll try to put 5 in the correct place, then we'll try to put a 4, then we'll try to put a 3, then 2, then 1, and so on. So if we'll successfully put a number at the correct place, within the recursive call we'll call the same function for placing an input which is 1 lesser than the previous element. So and this will go on in the recursive stack inside and inside, and thoroughly if we will successfully place all the elements, that function will be returning true. And at last if all the elements are placed successfully, we can just return the successful elements, the placing of successful elements as the output. Otherwise we will be giving not possible as our output. So the second step says one successfully placed, recursive attempt to place n minus 1, n minus 2, and so on until all numbers are placed. If at any point a number cannot be placed, we'll be backtracking by removing the last placed number and trying a new position. So why we are coming with the backtracking approach is also a thing which we must take care of. Whenever we see a question, when we are checking pick or not pick, so this is a pattern which we need to basically find out from the question, that this is a question we can basically solve using backtracking, where we can backtrack to the previous position, change the last element placed, and then again try the placing in the next step. So we'll be seeing the code for the algorithm of this problem statement. So this is the code of the algorithm for this problem statement. We are just starting with a num placement class, where first of all we are taking an input in the console. So this is in code in Java, where we will be taking an input in the len variable, and then we are passing it through the generate array function, which is being put in up here. The function of the generate, the working of the generate array function works as like that. First, this function will create an array which will be basically the size of 2 into len. Since we need to place all the elements in the array of double the size of the input just fed up, and then we'll initialize the array. All the elements will basically initialize with array. We are using an inbuilt Java function arrays.fill. So we'll be inputting 0 in all the places of array, and then we are just calling the function, uh, the backtracking function can place, which will try to place all the elements in the element at appropriate position. If the function will be returning true, then we'll just print out the elements one by one. Otherwise we'll be outputting not possible. Now let's see the function can place, which is playing a major part of the problem statement. Here we are just passing out our array, the input that is being fed up 2 times, which will be, we can see, we will be seeing in the next slide why this is being passed on 2 times. So let's see how the can place function works. So if we'll see, for example, we are taking an input n equal to 3. So the first thing that we will get is an array of type int, which is basically of size 6. Now in the can place function, we are keeping an num equal to 0. This is the base condition, where we will be returning true. This is for the condition if for example we are trying to place 3 2 1, when it will be coming to 0, basically it will return true, since all the elements are successfully placed. This is the base condition we should keep. And the next loop that is running is for I equal to 0. It is running till I plus num plus 1 less than 2 into len. So let's just see through what is I, what is num, and why we are doing this increment. So I is basically the current iteration, is basically the indexes where we will try to put up our element. Num is the element which we are trying to place at this time. For example, the first call will be basically for the last element 3. So it will try to place 3 at this point, and the last one is our len, which will basically be the same throughout the call, because that is the length of our function. So let's just call it, let's just try to fill it up everything for our n equal to 3, and we'll see if it will not be able to place some element, we'll backtrack to the previous call. So when n will be 3, the first thing we'll be getting is I equal to 0, and since I equal to 0, 0 plus num is basically 3 at this point, and this plus 1 is for placing the second instance of 3. Is, for example, if I equal to 0, we'll try to place the 3 as the first index, and then the second instance of the 3 we will be 3 elements apart from the first instance. So this will determine the position of the second instance of the element, and this should be less than the total length of the array. That will only determine whether it is a successful position or not, and then we'll be keep incrementing I to place other elements. For then we'll be going inside this call, we'll be checking whether the position is currently empty or not. If array of I of 0 and array of 3 plus 1 4 is 0, if we will see that the both of the elements are currently empty, then we can successfully place the first element of the array is 3, the other elements are 0, the fourth element is 3, the last element is still 0. So this is the thing that happened in the first loop, and then at the same time we'll be calling the function recursively whether we will be able to place this array we are passing along with next a smaller element, and then we'll be passing the array size. Now we'll try to place 2, whether we are able to place 2 or not. Since 3 is placed, if it will create some problem placing 2, we need to backtrack to the previous position. Now when this time when n is equal to 2, again the loop will start from I equal to 0, and it will go on. And here, since the difference between the two instances of 2 will be the two elements, so I is 0, so 0 plus we're trying to put up 2, and the next index where the second instance of 2 will be 1 apart. It should be less than our 6, the size of our array. So this is success. It is passing the condition. We'll be going inside, we'll be checking if array of I, which is basically 0 for now, is 0, and array of 2 plus 3 is 0 or not. We can the array at the current position, we'll just write it here. This is the array that is currently in this form. So you can see array of the first element in our array is not 0, so it will not go inside the if loop, inside the if condition, and it will be relooping the for loop. The next time it will be I equal to 1, and when we keep I equal to 1, our the next index will be 1 plus 2 plus 1 should be less than 6, which is basically 4. So again, if we see the first element is 0, but if we see the fourth index, which is basically 0 1 2 3 4, it's occupied by another instance of 3. So again we'll not be able to enter the if condition. So the third time when I will become 2 and is 2 plus 2 plus 1 is passing the condition, so it will going be inside the if condition this time, and it will check if array of 2 and array of 5 is 0 or not. So if we see array of 2 is currently 0, and if we see the array of 5 is 0, so it's passing our condition. So we'll be putting 2 in these two instances. Let's see that. Let's just rub it for now. So the after placing 3, we have got 3 0 2 0 3 and 2. Now within the call of I equal to 2 of when the element, when the num was 2, at that same place we will be calling if it can call array with 1 and it is still 3. So now we're trying to place the third element, which is 1 smaller than 2, the 1 element, at the correct position. In this recursive call, again the loop will start from inside where I equal to 0, and we can see 0 plus the num is 1, and there should be a difference of 1 element between the two instances of 1. It should be less than the length. It is passing the condition, so we can enter the for loop. Now we need to check whether we'll be able to enter the if loop of the can place function here. So we can just check if array of I, where I is 0 currently, and array of I plus num plus 1, which is basically our 2. So array of the first element of element is not empty, so we'll not be able to enter the loop. So the for loop will continue and we will be getting I equal to 1. Now you can we'll see if for one for I whether we will be able to enter the loop and put up the element 1 at the correct places. So when I equal to 1, the condition is getting satisfied since 1 plus 1 plus 1 is less than 6. So whether we can enter the if loop or not, let's check that. If array of 1 and array of basically is 3, yeah, 3 is empty, if both are equal to 0, we'll be able to enter the loop. So we can see the first element and the fourth, basically first, second, third, fourth, yeah, the second and fourth. Why, if we can see through 0 indexing, it's just the index 1 and index 3, both are empty. So we can successfully place array of 1 at 0 and array of 3 as also sorry, it's we can place 1 at both the places, 1. So after placing the two elements, the array is looking something like this, where we can see between the two instances of 1 we can see a single element, between the two instances of 2 we can see two elements, and between the two instances of 3 we can see three elements. This is what was the expectation of the question, and it will not stop here. If you see, after successfully placing 1, it will try to call array the can place algorithm with the can place function with the array, and this time the num minus 1 is basically 0 and 3. So when it will call num equal to 0, we can say it will return true. So here if it returns true, it will return true to the calling function, which was basically the function when num was 2. So let's just scrub it for now to go back to the previous function. So this will be returning true to the function when num equal to 2, and for that function it will be returning true to the function that called num equal to 2, which is basically the function that is num equal to 3. And at last, this all we since we were able to place all the elements at their positions, it will be returning true to the generate array function. And there we will be able to print out the elements one by one. Similarly, if we can check when if for example n will be 1, we will try to place 1 since we can initialize the element like it's a 0 0, and if we try to place 1 separating by 1, two instances of 1 separated by one element, it is not possible since the length is not bigger than 3, so it will just return not possible as the output. So it's the approach how we go through, and we need to search for the pattern which will basically solve the question. Here it was backtracking, so it was a question of whether picking the element or not picking the element, and trying to backtrack to displace element which was previously placed. Now let's see the complexity of the question. If we see the time complexity of the question, in the worst case it is calling the function can place every time with the array, the num and the length. So for n it can be n possibilities, for n minus 1 there can be n minus 1 possibilities, and similarly So the worst case time complexity we will be getting is order of n factorial for the question. And if we see the space complexity, we are just using the stack, like the external we are just using the array, and we are just incrementing it. We are just multiplying it by 2 for storing the elements. So it will be order of 2 n. We can just keep the constant now. So it's basically the space complexities we are getting is order of n. So this was all about the problem statement that we got, where we were expected to get put two instances of the element separated by n elements. If we were not able to put, we should be returning not possible. Thank you.